G'day everyone, and welcome to Island Technologies presentation on Draytech switching solutions. Today I'll give an overview of Draytech's range of switching products to suit small to medium-sized business applications. When used with Draytech routers, you can have an integrated platform to manage and configure your network. My name is Java, and I'm a technical sales specialist here at Australia and New Zealand Draytech. Here's an outline of what's going to be covered in today's session. Starting out with an overview of Draytech Vigor switches and where their names come from. We'll take a look at the types of Vigor switches Draytech have before taking some time to talk about the various features. We'll also look at how they can be centrally or remotely managed. If you have any questions during the video, simply comment in the chat box on the right side of your screen and stick around at the end for a 5-minute Q&A. If you're watching this after the live premiere, please comment below or send an email to sales@draytech.com.au. So it's time to begin. Let's start by getting an overview of Draytech's Vigor switch range and what the differences are between different model types. Before we get into the different types of Vigor switches, let's quickly talk about the naming convention that's used for these products. The Vigor switch model name includes details such as the type of switch it is, the type of management used, the number of ports, the serial number, and the uplink specification. Let's have a closer look at each of these. The first two letters in the Vigor switch model name indicates the type of ports that are available. The letter G indicates gigabit Ethernet ports. The letter P indicates that the Vigor switch has PoE capability to provide power to attached devices. X indicates that the ports are 10 gigabit capable, and F indicates that it has optic fiber ports. The next digit refers to the management type. 1 refers to Smart Light or WebSmart. 2 refers to Layer 2 or 2+ management. And 3 refers to Layer 3 management functions. Here we have more details on the different types of managed switches. Smart Light is the most basic switch with minimal configuration required, and it's used for simple network installations. The next one up is the WebSmart, which has additional features and config options. It can also be managed by Vigor ACS2, Vigor Connect, or the central management feature of Vigor routers. Up from this, we have the Layer 2 switches, which have additional Layer 2 functions. And the most advanced are the Layer 2+ switches, which also include basic Layer 3 features such as routing and DHCP. These switches help to improve network performance by reducing the load on the router by more effectively routing local traffic. So if the router will only need to route traffic going out to the internet. The next two digits show the number of ports in the switch. And the last digit is the serial number. Some models have a lowercase letter behind, which is the uplink spec. Here the letter X indicates that the Vigor switch has some 10 gigabit Ethernet ports. An example is the P2280 Vigor switch. The name indicates that it is a 28-port PoE Vigor switch with L2 management. Let's now look at the different types of Vigor switches that are now available. We covered the differences between the different types of managed switches previously. Power over Ethernet or PoE switches have the same functions as managed switches, but also supply power to attached devices such as IP cameras, IP phones, and so on over the Ethernet cabling. The most basic WiGA switch type is the Smart Light series. These WiGA switches require minimal configuration and include features such as VLAN, QoS, IGMP, loop prevention, and port mirroring. These are suitable for simple network installations. An example of a Smart Light switch is the 8-port WiGA switch G1080 that's shown here. The next type is WebSmart WiGA switches. These have additional configuration options compared to the Smart Light switches. Additional features include spanning tree, SNMP, DOS defense, etc. These are suitable for scalable networks and can be managed by WiGA ACS2. Examples of WebSmart WiGA switch are the WiGA switch G1280 and P1280 shown here. The next type is Layer 2 managed WiGA switches. When compared to the WebSmart WiGA switches, these have additional config options which include IGMP Queria, GVRP, and surveillance VLANs. Additional security features include access control lists or ACLs, 802.1x, IP source guard, radius, TACACS, and AAA, etc. Two examples of Layer 2 managed WiGA switches are the WiGA switch G2121 and P2121 that are shown. There are several others as well, which you can find listed on our website. The next step up is Layer 2 Plus managed WiGA switches. These switches include basic Layer 3 features such as static routing and DHCP. They are suitable for large networks and can improve network performance by handling local routing as well as DHCP services, thereby reducing load on the internet router. Two examples of Layer 2 Plus managed WiGA switches are the WiGA switch G2540X and P2540X. These models also have 10 gigabit ports as indicated by the X in their name. There are several others which you can find listed on our website. Layer 2 Plus functions are covered in more detail in another webinar that we've got in the current series. I've included a link to that in the description below. Well, now that we've looked at the variations between the different types of managed switches, we can have a closer look at PoE switches. PoE is an abbreviation of Power over Ethernet. These switches have the same functions as the managed switches, but also supply power to attached devices such as IP cameras, IP phones, and so on over the Ethernet cabling. Dratec WiGA switches use PoE mode A to supply power to PoE devices. Mode A is also known as N-span, and power is supplied over data pairs 1, 2, 3, and 6 in the UTP cabling. A PD discovery process is used, as shown in the flowchart on the right, to check if a PD device is attached before bringing up power on the switch port. This prevents damage to any non-PoE devices that may be attached to the switch ports. Dratec WiGA switches support the 802.3AF and 802.3AT PoE standards. 802.3AF can deliver up to 15.4 watts per port and is suitable for IP phones and access points. 802.3AT can deliver more power, up to 30 watts per port and is suitable for IP cameras or other devices which sometimes require more power. Each VIGA switch will have a power budget rating in its specifications, and this is the total amount of power which is available to the PoE ports of the switch. This will vary depending on the switch model and can range from 140 watts up to 400 watts. Now, this is something that you'll need to check to ensure that the switch selected has the right specs to power all of your PoE devices. For instance, a PoE switch with a power budget of 140 watts can provide enough power for 4 IP cameras at 30 watts each and an IP phone at 15 watts to give us a power load of 135 watts. Listed here are some additional features of Tradetech PoE VIGA switches, including the option to set a power limit to each switch port of either 15.4 watts or 30 watts. Also, devices can be restarted by power cycling them at pre-configured times according to a schedule. This can be handy for devices that have a tendency to get locked up and freeze and other issues. In addition, there is the device check feature where the VIGA switch can send ping packets to check if the device is responsive. If the attached device becomes unresponsive, it can be power cycled by switching power off and on for that LAN port. We'll now briefly look at some interesting features that are available in VIGA switches. First up, we'll look at link aggregation, which is achieved using Link Aggregation Control Protocol, or LACP. Here, 2 or more switch ports can be combined to achieve a much higher bandwidth trunk connection between 2 VIGA switches. For instance, we can aggregate 2 gigabit ports to give us a 2 gigabit link between the switches, and up to 8 ports can be aggregated into a single group. An additional benefit of link aggregation is that it provides redundancy if one of the physical link fails. Link Aggregation Control Protocol, or LACP, enables a higher bandwidth connection to be established with supported devices such as servers and NAS devices. LACP is a control protocol to enable LAG, that is Link Aggregation Group, to automatically configure network switch ports, detect link failure, and activate failovers. Another feature is port mirroring. This is a handy diagnostic tool in Tradetech VIGA switches to forward ingress and egress traffic, that is TX and RX packets, from selected switch ports to a switch port that's connected to a network analyzer. The quality of service, or QoS feature, is found in higher-end VIGA switches. Here, traffic on certain ports can be prioritized. Traffic can be tagged for QoS by using COS, DSCP, or IP precedence. Some VLAN traffic types, such as voice and surveillance VLANs, can also be tagged for quality of service. Now, shown here are a number of security features in Tradetech VIGA switches. We have IP conflict prevention, which I'll go into more details shortly. SSH, SSL, and SNMP version 3 are also supported to provide secure management. IP Source Guard is another feature, which blocks illegal IP addresses from accessing specific ports or receiving data packets. IEEE 802.1x port security is also supported. The Access Control List feature ensures that only authorized users can access designated network resources. In a large network, if a rogue device is introduced with a conflicting IP address, it can cause network stability issues as well as interruptions. Troubleshooting this will also be time-consuming. To remedy this, Dratec introduced IP conflict prevention in the latest firmware versions for Vega switches. The switch will identify the port where the rogue device is attached and alert the network administrator to take action. In the meantime, the rogue device will be blocked on the Vega switch. IP conflict prevention will also work on larger networks with multiple edge switches not supporting this feature. In the example shown here, we have an edge switch that's connected to the Dratec core switch. If PC4 conflicts with PC1, it will be blocked on the core switch, but can still communicate with other hosts on the edge switch, such as PC3. If PC2 conflicts with PC1, then PC2 will be blocked since PC1 is configured to have a higher priority to use the IP address. When an IP conflict occurs, the details are shown in the web interface of the Vega switch. Here we see that gigabit Ethernet ports 1 and 12 are conflicting with port 2. The network administrator will also be notified if the notify option is selected. The port servicing the DHCP server can also be selected to prevent other DHCP servers from being introduced on the network. The Spanning Tree Protocol, or STP, is a network protocol that ensures a loop-free topology for any bridged Ethernet local area network. Dratec Vega switches support 3 types of spanning tree protocols. These are IEEE 802.1d Spanning Tree Protocol, 802.1w Rapid Spanning Tree Protocol, and 802.1s Multiple Spanning Tree Protocol. The diagram here gives an overview of spanning tree. The root or master switch interacts with the other switches in the network to ensure that only one route exists between 2 stations and provides backup paths if the primary link goes down. We'll now look at 3 management platforms that can be used to manage and configure your Vega switch. These 3 management platforms include Central Switch Management, Vega Connect, and Vega ACS2. I'll go over each of these now. Central Switch Management is a feature in Dratec Vega routers that provides a central console to manage and deploy supported Vega switches. It also simplifies setting up VLANs on the switch to match the settings on the router. On the status monitoring page, the router presents a hierarchical view of the Vega switches on its LAN, where you can easily find a device in the network topology. The colored icons shown the different state of the Vega switch ports. These include uplink, downlink ports, if a port's in use or are available or are in shutdown mode. Clicking on a switch port will show the port status. Here you can see port information, and you also have the option to shut the port down. The router offers a simple method to plan VLANs on the Vega switch. It presents the VLANs available according to the router's configuration. The port connecting to the router is automatically set to a trunk port, and you only need to define PVID when a port is a member of multiple VLANs. In the switch status menu, you can see the status of all the attached switches at a single glance. You can see the switch name, its IP address, the model number, and system uptime. You can also see how many ports are in use on each switch, as well as how many clients are connected. When we have more clients than ports, this can be due to connections coming through an attached switch or access point. In the Central Switch Management Maintenance section, you can back up or restore the switch configuration. You can also reboot the switch or reset it back to factory default settings. You can select from the existing devices on the left and move them to Select a Device section and apply the required action. Before we finish, I'd like to show you a short video that demonstrates the Central Switch Management feature in a VIGA 2925 router. This is similar in later router models.
Hello everyone. Central Switch Management is a feature that is available in dual WAN and multi-WAN routers. It allows you to configure and manage Draytech VIGA switches connected to the router LAN from a single console, greatly reducing the workload needed. In this video, I will show you how to use the switch management feature in VIGA routers. We first need to enable external device discovery in the router. To do this, go to Central Management, External Device menu, and enable the External Device Audio Discovery option. Then, connect a VIGA switch to the VIGA router's LAN port. Wait a few seconds for the VIGA switch to be detected. When the online device is shown, it is ready to be managed with Central Switch Management. Go to Central Management, Switch, then Status menu. You will now see the VIGA switch is in the switch list. Clicking on Switch Hierarchy, the switch connected behind the VIGA router will be displayed here, and upper switch if there is one. We can also monitor the basic information of each port on the switches. Network administrators can register 10 VIGA switches to SWM on each VIGA router. Also, it supports the switch on the second layer. Then we're going to configure the switch. Click Profile, then on General tab. We can set the switch name, comment, and the login password. Please make sure to enter the correct password here, otherwise the router may not be able to get the information and manage the switch. On the VLAN tab, network administrators can set the VLAN settings to each port, including the PVID and VLAN membership. The VLAN settings of the router will also show on this page. Take this scenario for example. The network administrator may want you to separate the network to different VLANs for staff, servers, and guests. Assume the network administrator decides to use port 1 to 18 to VLAN 0 staffs, port 19 to 21 to VLAN 1 server, port 22 to 26 to VLAN 2 guests. He can set the VLAN setting to each port. You may have noticed the icon changes with the different settings. Trunk port and hybrid port are indicated by a switch on the black base icon. The blue background with a monitor icon represents the access point. On the Port tab, network administrators can enter the description of each port. It will also be printed out on the switch hierarchy. Here, we can also set the shutdown schedule to each port. For a power saving example, network administrators could disable or enable the port by schedule. Click the list on Port Control and choose by schedule. Then put the index in the schedule. Click Save to apply settings. For adding a new schedule, click Schedule. It will take you directly to the schedule page. Click in Index, set the start date, duration, and action. Click Save to apply settings. After setting up the schedule, Send to Device is necessary to send the configuration to Vigor switches. After setting up the switch, we can go to Switch, then Maintenance. On this page, network administrators can execute config backup, restore, remote reboot, or factory reset on each switch. In the past, network administrators would need to log in to each switch's WUI to do such things. Now, we can perform these tasks on a single page.
Vigor Connect is another central management solution for Vigor switches. It is a TR-069 based central management system that's available as a free download from Dratec. You can use it to manage up to 100 Vigor switches on the LAN. It's been covered in detail on a webinar we ran previously. I've included a link to that in the description below. Now, some of the key features of Vigor Connect are device discovery, where all the Vigor switches will be discovered and auto-configured to add to Vigor Connect. Provisioning, where pre-configured profiles can be uploaded to each switch. Real-time network status monitoring will send you a notification if a switch has lost network connectivity. Visibility gives you insight about the Vigor switch as well as CPU usage over a specific period. And maintenance tasks such as firmware updates or configuration backups can be done according to a time schedule. Setting up VLANs is also simplified when using the graphical view in Vigor Connect. The last central management system that can be used for Vigor switches is Vigor ACS2. This software is a subscription-based system with all the features of Vigor Connect, but it can manage a greater number of devices based on the software license, and it can also manage devices anywhere on the internet, not just a local area. Vigor ACS2 was covered in great detail in one of our previous webinars. Please get in touch with us at Sales for a free 30-day trial of the product. So, to summarize, today we looked at an overview of Dratec Vigor switches, including the naming convention used to help you identify the switch features based on the model number. We looked at the different types of switches, which included SmartLight, WebSmart, Layer 2 and Layer 2 Plus, as well as PoE, and what the main differences were. We also discussed a number of Vigor switch features listed here, as well as the central management platforms which are now available. Okay, that's it for me, but please do stay tuned. Staff will be answering questions in the live chat on the right of your screen for the next 5 minutes. And for more information about Dratec products, please check out our website at www.dratec.com.au or send us an email to sales@dratec.com.au or give us a call on 0298 388 99. Don't forget to like and subscribe below. And if you'd like a notification of new Premiere videos we're about to launch, or anytime we put up a new video, please give the bell a click too. Thank you very much for your time today. I hope you found the session fun and informative. Until we meet again, goodbye.